about limits as x approaches infinity, and when you're dealing with x as it approaches infinity, you're dealing with horizontal asymptotes. Now when you're dealing with horizontal asymptotes, you can think about the y equals form. So you're dealing with a number set that's equal to y. Now that you're dealing with x and y planes, so one of the easiest ways that you can tell before even actually dealing anything with the problem is if you have a problem that says x, y, f of x equals x squared minus 2 over x minus 2. What you can tell is by the degree of the function. So you have a top-heavy function, meaning that you're not going to have a horizontal asymptote, as you can tell. The top one is heavy, so you have top-heavy equals no horizontal asymptote. And it's going to be a limit as x approaches infinity. Now, when you have bottom-heavy situations, when you have f of x when the limit as x approaches infinity, when you have the same situation, x minus 2 over x squared minus 2. Now you have a bottom-heavy situation, meaning that you will have a horizontal asymptote as x approaches infinity. And when they're proportional, so you have f of x and the limit as x approaches infinity is x squared over x squared, then what you can do is take the coefficient of these two numbers. So when they're both 1, you would set it 1 over 1, and it would give you what the horizontal asymptote in this given function would be. Now I'm going to work a simple problem out that I have set. I'm now going to work this simple problem with you real quick. So if this camera can just zoom in a little bit, we'll have the function being limit as x approaches infinity of 3x plus 5 over x minus 4. So now the first thing that we're going to have to do is going to divide everything by x. So we'll have the limit as x approaches infinity being 3x over x plus 5 over x minus 4, all divided by x as well. So you're going to have, these are going to cancel out, leaving you with the limit as x approaches infinity, leaving you with 3 plus 5 over x over 1 minus 4 over x. Now when you have a situation like this, you're going to know that these are going to automatically bump out each other to being 0, so you don't have to worry about these. And then you leave them with the proportion of being the limit as x approaches infinity, 3 over 1 equals 3. And that right there